So let's see. When we're talking about the linked string implementation of stack, in this case, okay, we were talking about those in Python. And so let's see. We use the node class to create an element in stack. And use a pointer top to point at the top element. And the stack elements are nodes in the object. So one by one. Then it means that the top element is in the top dot element. That is, you can see the difference. This element is actually pointing at the content of the node. It is stored. And top is actually the pointer, as mentioned, pointing at the node. Okay, so if we draw it out, it will be a node, right? There's a pointer pointing to it, which is called top. Right? Okay, all of them is actually node. Okay, it contains an element. Okay, it contains some sort of element, right? So, but bottom elements is in the top next. Okay, one by one. Remember about the chain log. Okay, you have one by one pointing one to another. Okay, so if there are 5 elements in the stack, the size is 5, and the bottom element is represented by top dot next dot next dot next dot next. Okay, one by one is each one is dot next. Okay, so this is the implementation, and you can find it from the link stack Python, which is given to you. Okay, here, this one. Okay, so the code is already given to you, and then you can see the whole set of code here. Okay, now let me introduce them. First of all, it's quite similar to that we learned on the linked list, and the node itself is as the next, and also it contains the element. Okay, it's going to store, and then it has the structure link stack, and the first one would be the top, which is the pointer initially pointing at nothing because there's no nodes in the chain first. But when we add some nodes there, then we will add the node, and the top will be pointing at the first one. Okay, that's the case. Then what is push? It is to add an element to the top of stack. Okay, so here you can imagine that actually we would create a node. Okay, if we want to create, then you can see that there's a node with an element instantiated, containing the active element, as a new node. This one is the new node. Okay, the element is the content, right? Okay. And then top next, this new node, the next is pointing at the top, right? Okay, the top is pointing at the first item, therefore it is pointing to the top, to the one top is pointing at. And then top is pointing at the new node. Okay, that is this one pointing at the new node, not the currently the first one. Okay, so it completes the train, and also it updates the size value. So it completes the overall operation of the push. Okay, that's the first case. And then how about peak? Peak, it means that it would just look at the first item. That is the first node. But remember, not removing any. That is, just see if the stack is empty. If it is empty, then just return a statement showing that it's empty. The stack is actually empty. If not, it would return the element pointed by the top. Now, remember, it returns the element, not the entire node, because the peak is looking into the content of the first node, not for the entire node. So it is the case of peak. And then, how about the pop? The pop has two actions. Actually, it returns the element of the top is the first action, and then it removes it. Okay, it also removes it. Then you can think about the logic. First, if the stack is empty, then just return. There's nothing inside the stack. It is natural. And then it would first have a variable try to contain the content of the first node, right? Okay, top dot element. And then the top has to change its position because this node will be removed. So this top pointer will point to the next. Okay, and then we move this link. With this, that is this statement. With this, then the size is reduced by 1, and then return the top element. Okay, this top element. And then the train will actually remove this node entirely. Okay, because there's no pointer pointing at this one. Okay, that's the case of POC. So how about empty? Empty is simple. If the top is actually pointing at nothing, okay, or none, or the size is actually 0, then you know that, okay, the stack is actually empty. Okay, so another one, as mentioned, we can get the stack size. Okay, knowing about the number of items inside the stack. So it can just return the size, because no matter you are adding a node or removing a node, then you actually update the size. Therefore, you can just return the value of the size. Okay. So it is the main operation of the stack.